Wonderful. Earlier in our BGP Path class, we learned various categories of attributes and we saw some examples. Some are well known, some are well known and discretionary, some are well known and mandatory. And if you see the attributes like AS path, next hop, origin, they are well known as well as they are mandatory. There should not be any BGP update without these three. If one of this is missing, update is not going to be accepted. Any update coming without one of this first three, any update that is coming without one of this first three will be invalid. Routers will not accept it. This shows that it is a mandatory one. All the mandatory one are well known. All the mandatory attributes are well known. But there are some attributes which are discretionary, like local preference. They are not mandatory, they are discretionary, meaning they may be present, it's okay, even if it is not there. There is some default value. There is some default value, even if you don't configure, there is going to be a default value which will be assigned. But for origin and next hop and AS path, there cannot be any default value. AS path means what? The autonomous system numbers path. How can there be a default autonomous system number? Not possible. How can there be a default next hop? How can there be a default origin? Origin explains how this network is introduced, whether it is advertised or redistributed. There should be something, either this or that. There cannot be something called null, default, none. Not possible. So they are mandatory, not discretionary. Whereas local preference and MED and all, if you see, even if you don't configure, it is okay, because there is going to be a default value. For example, the default local preference value is 100. The default MED value is 0. We'll talk about this local preference, MED in detail. These are all the names of the attributes. There are much more attributes, and the sequence in which the attributes are verified is not this one. This is not a sequence. This is not in order. We'll talk about the sequence after a few slides. Now, about this AS path attribute, I explained in the previous class. The next autonomous system, the immediate autonomous system from where we receive the updates, will be reflecting as the first number, and the autonomous system from where it originated will be the last number. When you see BGP updates, the last number is the place from where this network is originated. And this number is the autonomous system number from where this router's autonomous system number received. This router belongs to different autonomous system. Router A is not a member of this. This is the neighbor autonomous system, and this is the IP address of the neighbor autonomous system. And then this router which has got this IP address belongs to this autonomous system. So immediate autonomous system number will be in the first, and the originator autonomous system number will be in the last. You may have in the path 15 autonomous system, 10 autonomous system, depends. It depends on how many autonomous systems in the path. Now, AS path is a well-known mandatory attribute. Okay, next of attributes, we learn next hop behavior. In that we learned next hop is the IP address with which we peer with the next autonomous system. So for router C, the next hop is not going to be router B, the next hop will be router A. For router C, the next hop is going to be router A, because that is from that autonomous system where A is, the network is advertised to be. Even though B is giving to C, when B gives to C, it will keep the IP address 10.10.10.3 as the next hop. So C will find next hop as 10.10.10.3. And this should be there always. There should be some autonomous system for router C. So it is mandatory. Later, when C don't know how to reach 10.10.10.3, we used to say next hop self on router B, so that B's address will reflect as the next hop. That is okay, but by default, the next autonomous system's IP address is what going to be the next hop address in all the routers inside 65000 autonomous system. About the origin attribute, I explained to you that there are two ways in which the network can be introduced into BGP. One is by advertising using the network command. The other one is redistributing. Smaller is preferred. Here I is smaller than question mark. And question mark is greater than E. E is smaller than question mark. Now what is E? Once upon a time, there was a protocol called EGP. Like BGP, there was a protocol called EGP. Let's say you have a router. One neighbor is EGP neighbor. The other neighbor is EBGP neighbor. And now this EBGP neighbor is advertising a network 1.1.1.1. EGP is also giving, EBGP also giving. In both, we advertised using network command. So router A will accept only this as the primary path because I is preferred over E. Smaller is preferred over E. And this attribute is advertised to everyone who is eligible to receive the update. To wherever this network is advertised, it will be always advertised with this attribute called origin. The other day I was telling you, in Houston, you use the network command and advertised. In Melbourne, Australia, when they learn the route after 10 autonomous system in the middle, it reaches Australia, Melbourne, they can very clearly see that they can very clearly say that in the originator place in Houston, it is advertised using network command. So the origin attribute is informed to all the autonomous system number in the internetwork, saying how the prefixes were introduced into BGP. What is the method followed? Was it via redistribution or via EGP or via network command? What is the way in which it is introduced? Yes, question.
How would you know? How would you know?
That's what I said. If you see here, I in Australia, and let's say this is the router in Houston. No, this is not Houston. This may be, let's say, Singapore. From Singapore, Australia receives this network. Let's say this is Singapore's autonomous system. And after Singapore, there may be many other numbers. At last, you have this number, Houston. And in Houston, they use the network command, and this router in Sydney can very clearly know that this is not redistributed, it is advertised. That's how it knows. So how is this possible? Because this attribute is informed to all the autonomous system in the internet work. And this origin attribute explains how the prefixes were introduced in Houston.
And if it was redistributed, what would be there?
Question mark. When you find question mark here, it means it's redistributed. In the originating place, they have redistributed. Let's say one neighbor is advertising this as redistributed, another neighbor is advertising this as advertised using network command. Which one will be preferred? Advertised will be preferred than redistributed. Is this clear?
Yes, it is.
All right, smaller is preferred. Now, local preference. Local preference is an attribute which is also well known, but even if you don't configure, there is going to be a default value, 100. It's discretionary. Another thing is this attribute is not advertised to other autonomous systems. It is advertised only within IBGP neighbor. Now, what is this attribute help us to achieve? It helps us to decide the exit. It helps us to decide how the packet to leave our autonomous system. For example, if you see this autonomous system 64520, in order to go to this autonomous system, you need to go to 65350. In order to go to that autonomous system, you prefer to exit via router 2. But by default, it won't exit via router A. By default, it won't exit via router A. Why? B is just having 2 hops. A has got more than 2. 1, 2, and 3. So by default, all the routers in this autonomous system, you may have many routers. All the routers in this autonomous system by default takes the shortest AS path when you don't configure any other attribute. But I don't like that. I want A to be the exit point. Why? Because I got more bandwidth here, let's say 100 meg, and I got only 10 meg here. So I want to exit via A. A really do not know that we have more hops, or the administrator did not focus. Administrator says, hey, see, I have a very good deal with this ISP, ISP2. ISP1 and ISP2, I prefer ISP2. The reason is ISP2 has guaranteed me security. They said we'll encrypt your traffic. Uh, I like to go via ISP2 because I got more benefits, not only bandwidth. So I don't care whether it is 3 hop or 10 hop. I prefer ISP2 than ISP1. And what I need to do is I need to go and increase the local preference value more than what you have in B. In B, the default is 100. And in this example, in B, they have configured as 150. So if you want to leave out from A, you want to exit on A, then you need to go and increase the number more than 150. You need to provide a number bigger than 150 on A. Now, as soon as you configure this on A, this will be advertised to all IBGP neighbor, and all the IBGP neighbor will know how to leave their autonomous system. So you don't need to go and configure this on every router in this autonomous system. You just configure it on A, and A will advertise this information to everyone in this autonomous system. And everyone will leave this autonomous system from A, not via B. The reason why it is not picking B is local preference come before AS. If it focused on AS first, then it would have taken via B because it is less hop. But in the sequence, when it checks the attribute to decide the exit, local preference comes before AS attribute. Local preference attribute comes before AS attribute, AS path attribute. That is why I said in this page, this is not in sequence. Actually, this comes before this, and this comes before this. Yep. So we'll talk about the sequence later. We are just learning what is local preference here. Is there any question on local preference?
No, sir. But you said local preference is locally significant.
Throughout the autonomous system, it is significant. It is locally significant. It's not local to the router. It is local to the autonomous system. So when you configure on router A, you see, local preference is used to advertise to IBGP neighbor. What does that mean? It is given to all IBGP neighbor. It is locally significant. Locally to what? Router? No. Locally to autonomous system. It is locally significant to the autonomous system. This attribute is not going to be advertised to EBGP neighbor. It is advertised to all IBGP neighbor, very clearly saying that. Next is multi-exit discriminator. Multi-exit discriminator, MED. MED stands for multi-exit discriminator. What is MED? What is multi-exit discriminator? See, this particular attribute is not applicable when you don't have multi-exit. When you don't have multi-exit, this is not applicable. You see, router A has got multiple exit. If router A wants to reach that 172.20.0.0, if router A wants to reach 172.20.0.0, it can go via B or C because there are two paths. But the owner of the network, who is this? This is the owner of the network, this autonomous system. They can influence you by setting MED lower. The default MED value is 0. Now lower is preferred because here it is 150 and here it is 200. B is advertising to EBGP. You see, local preference is advertised only to IBGP neighbor. Thus MED is advertised to EBGP neighbor. Thus MED is telling to A, if you want to come to me, B is telling, if you want to come to me, the MED value is 150. When C advertises this network, it says, hey, if you want to come through me, my cost is 200. My metric is 200. Which one you prefer? Now, A will prefer B now. A prefers B. Why? Because B is giving small MED value compared to C. MED is also called as metric of BGP. The path with the lower MED value is more desirable. MED is used to advertise to EBGP neighbors saying how to exit their autonomous system. So this MED is dictating A how to exit. It is advertising the autonomous system of A how to exit in order to reach 172.20.0.0. The MED attribute is an optional non-transitive. What is optional non-transitive? Optional non-transitive. It should be there actually. If it is not there, it will be discarded. So there should be at least 0. MED, even though it is an optional, it should be there. You see, MED is always between EBGP, there should be some value. If it is not there, even though it is optional, it should have at least 0. If it is not there, it will be discarded. That is why it is called as optional, non-transitive. Is this clear, MED?
Yes, sir.
Now next is wait. Wait is also same like local preference, but differs in one way. What? Wait is local to the router, whereas local preference is local to the autonomous system. Wait, when you configure, it is only for that router. But when you configure local preference, it is not only for router A, it is for every router. The advertisement will go to every router. Whereas wait attribute is not advertised to anyone. It is local to that router only. Wait is not sent to any BGP neighbor. Any includes IBGP and EBGP. Higher weight is preferred. For example, A wants to leave the site. So you give more weightage to this B neighbor. You go to A and say the neighbor address of B and give big number. So when B and C advertise the same network, when B and C advertise the same network to A will decide based on the weightage. B is considered as high weightage neighbor. So A will decide to go out via B. A will show more interest on B rather than C. Even though they both give the same network, A prefers to go via B. And it is only that A router in this autonomous system. If you have many more routers in the same autonomous system, it won't go like this. It will only go as per other attributes. Wait you have set only on A. So it is only for A. Whereas local preference, though you set only on A, the local preference is for all routers in the autonomous system. That's the difference. Wait also decides how you exit this router in this autonomous system. How you exit. This wait can be configured anywhere. It can be configured with EBGP neighbor. It can also be configured with IBGP neighbor. No problem. You can configure it with EBGP as well as IBGP. All right. So this is important. These are important attributes. What we have seen are important attributes. What comes next is a different story. How BGP elects the path, and then this attribute list, the sequence, and then we will go to the lab exercises. But what we have seen so far, like local preference, AS path, MED, wait, origin, these are the attributes that are tunable. These are the attributes which most of us will be always using in order to achieve the BGP path as per the policy. What comes next is how these attributes can be used, where it can be used, what comes first and what comes next. I think we should do it in a separate day, otherwise it will be too burden. We'll start